prior to some interruptions, we have been talking about the Sertoli cell processes as this umbilical cord-like structure that's going to phagocytize a lot of the excess cytosol of the spermatid and help it become a sperm, a fully mature sperm cell. And I use that term widely because it doesn't yet gain the ability to swim until it's passed through the epididymis. But the acrosomes, we talked about that as being the hydrolytic enzymes from the Golgi bodies that help break into that wall of the egg cell. And there's the picture of the battering ram and the medieval style castle wall there. And another element of these sperm cells is a lot of these mitochondria. Now, why do we need mitochondria? Because we need ATP to power those dyneins to help contract the movement of this flagella by this microtubules that are arranged in these 9x2 fashion. And so, and a lot of people don't, talk about, say that, well, in today's, they wonder how much natural selection is still at work. And I'm going to take some of the Khan Academy's words from here and say that when an egg is fertilizes by a sperm cell, it's competing against 100 to 200 million sperm cells, and that is a genetically unique sperm cell amongst all of these hundreds of millions of sperm cells. So this is a I think the fact that I am the way that I am is very unique and very, I guess awe-inspiring when you think about the possibilities of what could have happened. So, and that's just kind of a quick, I guess, kind of dozing off subject there. But I also want to point out that it's the fructose is with this mitochondria. Why it's fructose and not glucose, I can't really tell you that. But that's, again, just kind of a general overview there. So now we're going to move on to the cilia. And I want to say that it's the pseudostratified ciliated epithelial that's going to move the sperm from the seminiferous tubules, to the rete testis, and then out of the efferent ductules to the epididymis. So rete, R-E-E. So the rete testis to the efferent ductules, and then the efferent, think about, they both have E's. Efferent leads to the epididymis. And from here in the epididymis, it kind of takes this, kind of a haste drawing, but it kind of takes this course like here, and then through there, up throughout like that. So this is the head, this is the body, this is the tail, and then from the tail it's going to travel up the vas deferens, and down to out through the urethra and everything else, which we'll talk about that process later. But anyways, what the epididymis does, the function of the epididymis is storage and maturation, and this is of these sperm cells. So we have these sperm, and this is a sperm cell is, it looks, as far as structurally goes, looks very similar. There's a few differences there, but it's lost a lot of its cytoplasm. It has an acrosome and all that stuff that we talked about earlier, but it doesn't quite know how to swim. It hasn't quite developed it. And so as it's going, it's got to storage and it's got to mature into a fully functional sperm cell that can penetrate into the eggs and do all the things that it needs to do. And as it moves down this epididymis, it has a lot of beta defensins that are kind of this, I like to think of them as this armored convoy that helps protect the sperm cells. And then they're also going to, it's going to phagocytize the sperm after several months. Not the beta defenses, though. The beta defenses are just antigens, or antibodies, I'm sorry. But it phagocytizes its sperm after several months. So basically what it's saying is that you don't use it. If you don't use it, you lose it. And this is kind of like something about a vasectomy, where they cut the vas deferens. Well, sperm is going to build up, and it will be, that will still happen. It's just going to build up in these tubules, and it'll be phagocytized if not ejected from the body. So the smooth muscle of the vas deferens moves the sperm out of the epididymis, and this is something that happens when the male is aroused, when he's watching porno. It's going to start to have this movement, this migration of sperm out of the tail of the epididymis up the vas deferens and into this little area called the ejaculatory duct right here. And on top of it and on the bottom of it, there are these internal sphincters, like obviously closest to the inside of the body, and then the external sphincters. And there's basically this and this is a gross oversimplification, but as sperm comes through here, it's in semen, it builds up here, and as this pressure gets builders up, it builds up, and that's kind of why orgasms feel like this up and down movement. If you've ever had one, it's that's what generates it, is this gradual, steadily increasing amount of pressure, which ultimately leads to expulsion of the semen out through the urethra. There's a lot of other processes that we still have to talk about, and so it's kind of like this prostatic urethra. It's not really prostatic urethra. It's the ejaculatory duct. I should probably clarify that. That's cool. Ejaculatory. Run out of room there. Duct is what builds up this pressure, and it's a lot of tension, kind of like an archer pulling back a bow, and it builds up. Once it starts to reach that critical level, he lets go, and the arrow flies off. So a lot of increase in pressure that will cause that. Okie dokie. Now, since we talked about sperm, we're going to talk about semen. Because remember that the fluid from the epididymis, the actual sperm, is actually 5%, maybe even less than 5%. I don't know why I wrote about varicoceles on there, but less than 5% of the actual semen is sperm. So what is the majority of it? Well, about 60 to 70% of it, 60%, I want to be clear that my book specifies saying 60, so I will go with what it says. 60% of it, that fluid, is from the seminal vesicles. And the seminal vesicles are, and I threw away my drawing, but if I could show you, there's these, as we, going through the epididymis and we land through, there's the prostate, whatever, there's these seminical vesicles, are these little jackrabbit looking ear thingies that kind of this little orange, I guess, honeycomb structures things here that they produce fructose. They provide fructose, which is, obviously going to be used as ATP for the mitochondria, which is an alpha glucose, remember that. And then they provide prostaglandins. Prostaglandins are local hormones, which is, I find that it's ironic that it comes from the seminal vesicle, but we call it a prostaglandin. But because they thought it came from the prostate. But, nevertheless, the name stuck. And what prostaglandins are local hormones, or autocrines is one they say. And what it's going to do is it's going to cause the peristalsis, which what does that cause? The rhythmic contraction, kind of like whenever you see a snake swallowing a mouse, that's peristalsis. What moves the food down your gut is peristalsis, but it causes the peristalsis of the smooth muscle of the vagina to pull the semen and the sperm towards the cervix. So here's, a picture. I drew it, and I don't know if that's a really well drawing, but there's people with oars, and it causes the vagina to contract rhythmically to pull that semen upstream and into the cervix, where it'll be enter the uterus, and things like that will happen. And it also causes, prostaglandins also cause the smooth muscle to contract peristolically in the urethra of males. So what causes this production of as it goes out, it causes, this smooth muscle contractions in the urethra of males as well. And it also, seminal vesicles secrete something called fibrinogen. Remember, fibrinogen is a basic form of a coagulant, and so once it becomes fibrinogen, and once it becomes that, it'll become fibrin is the active form. But this is the inactive form of fibrinogen, and what it becomes is a coagulant, so the sperm can be very, very sticky, so that it doesn't fall out. As you know, in the female reproductive tract, it's got to go upstream. Gravity is not necessarily, depending on the position, in your favor of this act that you're trying to do. So you want to have a lot of coagulants to help that sperm stick to the interior lining of it, or to help the semen, stick to the interior lining, so it doesn't just fall right out. And you also want to have alkalotic fluid secretions, because the pH of sperm is most optimal at 7.3 to 7.7. And this is something that I think is kind of just, it's not disturbing, but it is what happens, is that the vagina has a lot of bacteria. It is not a sterile place. It has a lot of normal flora as well. And it's not like, it's in your mouth, the anus, and the vagina. Really just the mouth and the vagina. Two places you're going to stick your penis. But they have a lot of normal flora, and a lot of homeostatic, a lot of homeostasis would be maintaining that stable environment, maintaining a certain amount of bacteria. And they actually don't get infections. And oh my God, who the